All right, let's get right into it. We hear about AI literally everywhere, but what's actually going on under the hood? Today, we're going to pull back the curtain and look at the real architecture of AI.
It all starts with something that sounds almost too simple. At their very core, these massive large language models, or LLMs, are just incredibly powerful next word predictors. Think of it like this train here. The model is laying down the track, piece by piece, just a split second before the engine gets there. It takes what you give it, and based on all the text it's ever seen, it just calculates the most likely next word, and then the next one, and on and on.
And yeah, that's an amazing skill, for sure. But the real game changer, the question that is pushing this whole industry forward, is this one. What if these models could go beyond just stringing words together and actually start taking actions, doing things in the real world?
And that, right there, leads us to our first big topic, the rise of AI agents. We're really talking about a huge leap in evolution here, from being simple word predictors to becoming complex, autonomous action takers.
So what even is an AI agent? Well, think of it as an AI that's been given a whole new set of powers. It's an autonomous system that can take a high-level goal you give it, figure out a plan to achieve that goal, and then, and this is the really critical part, it can use tools like searching the web or running other software to actually execute that plan and get the job done.
And the pace of this has just been unbelievable. I mean, look at this chart. It shows the landscape of major language models, and you can just feel the sheer speed of innovation. This is the engine that's powering these new agentic AIs. We're not talking about one or two models a year. We're in a constant flood of new releases, with giants like Google, OpenAI, and Meta all trying to one-up each other. It's this crazy competition that is making the core intelligence behind these agents more and more powerful really fast.
And this just shows you what that race looks like in real time. It's this dizzying cycle of, hey, we're introducing the world's most powerful model, only to have that title snatched away weeks or sometimes even days later. This isn't just marketing hype. This is the hyper-competitive world that's building smarter, more capable AI that can actually function as an agent.
So how does an agent actually do its thing? Well, it basically comes down to a simple four-step loop. First, it takes your goal and really understands what you want. Second, it thinks, okay, what tools do I need for this? Do I need a web search? Do I need to run some code? Access a database? Third, it maps out a step-by-step plan. And finally, it gets to work, executes that plan, and learns from the results to see if it needs to change course.
All right, let's make this super concrete. Let's say you give an AI agent a pretty common task, right? Can I get a refund for product foo? Now, a simple chatbot might just send you a link to a generic policy page. But an AI agent, it's designed to actually solve the problem for you.
But here's where we hit the first big hurdle. For our agent to actually process that refund, it can't just rely on its general knowledge of the world. No, it needs specific, accurate, and totally up-to-date information. So what kind of information are we talking about?
And this brings us to the next absolutely critical piece of the puzzle, the data dilemma. Because it turns out you can have the smartest AI on the planet, but it's completely useless if it doesn't have good, clean data to work with.
So for our refund example, the agent has this kind of shopping list of data it needs. It needs the official, up-to-the-minute company refund policy. It needs to pull up your specific order history. It needs the right info for that product. But here's the real catch. All of that data has to be accurate, it has to be consistent, and it has to be available right now. If any one of those things is off, the agent is going to fail.
And this really is the fundamental choice every organization has to make. On the left, you've got data chaos. This is, honestly, the default for a lot of places. The data is messy, it's inconsistent, you can't really trust it. And when you let an AI agent loose on that, you get errors, you get wrong answers, and you get what we call hallucinations. That's when the AI just confidently makes stuff up. But on the right, you have data order, a clean, standardized, single source of truth. And that is where an AI can find reliable info to make truly accurate decisions.
So, the big question is, how do you get to data order? Well, that leads us right to the foundation of the entire system. We have to architect the data itself. A great way to think about it is like you're building a perfectly organized digital library for the AI to read from.
The classic, time-tested solution to this is something called the Enterprise Data Warehouse, or EDW. Its entire reason for existing is to be that single source of truth. Think of it as that central library where all the data is organized by subject, like sales or customers.
It pulls in information from a ton of different sources, it keeps a historical record so you can spot trends, and it's built to last. New data gets added, but the old stuff doesn't just disappear.
Now look, this isn't the sexy, flashy part of AI that you see in the headlines, but I'm telling you it is absolutely the most critical part. This data architecture, it's like the invisible scaffolding that holds up the entire skyscraper. Without it, the most advanced AI model in the world will just come crashing down.
So where does this amazing digital library actually live? Well, these days, it's almost always in the cloud. But that comes with its own set of choices, mainly boiling down to what we call multi-cloud and hybrid cloud systems.
A multi-cloud strategy is pretty straightforward. It just means you're using services from different public providers. You might use Amazon Web Services for their storage, but then use Google Cloud for their slick machine learning tools. You're basically picking the best of breed for every single job. A hybrid cloud strategy is a little different. That's when you combine a public cloud with your own private on-premise data center. You see this all the time in industries like banking or healthcare, where they have serious security or regulatory reasons to keep certain data locked down in-house.
Okay, building this incredible data foundation is one thing, but we absolutely have to make sure it's used safely and ethically. And this brings us to the rules of the road, building with trust and security. I want you to really let this quote sink in. It's one of the most chilling things that came out of the whole Cambridge Analytica scandal. And you know why it's so chilling? Because it wasn't a hack. Nobody broke through a firewall. The system, which let an app developer scrape the data of not just the people who took a quiz, but all of their friends, that system was working exactly as it was designed to. This was a complete and total failure of data governance.
And that's where data governance comes in. It's the formal rulebook, the policies and procedures that make sure data is managed correctly. It's all about who can access what data, how they're allowed to use it, and how it's protected. And in a world with regulations like Europe's GDPR, this is not optional anymore. It's absolutely mandatory.
A huge part of governance is just data classification. I mean, not all data is created equal, right? This table shows you exactly how it works. Things like employees' social security numbers, obviously that's restricted, highly sensitive stuff that needs maximum protection. But anonymous clicks on a website, that might be classified as public or internal. The point is, how you classify the data dictates the level of security you absolutely must build around it. And all of this brings us to our final section, where we're looking ahead. Because as these AI agents get more and more powerful and autonomous, the biggest challenge we face isn't technical anymore, it's ethical. The future has to be about responsible AI.
A massive piece of that responsibility is transparency. For a long time, complex AI models were basically black boxes. We knew they worked, but we had no idea how. That's where this field called explainable AI, or XAI, comes in. Tools can now produce charts like this one that let us peer inside that black box and see exactly which factors pushed a decision one way or the other. In this case, you can see the hour of the day and the indoor temperature were the biggest drivers for a prediction. Being able to see the why behind an AI's decision, that is absolutely essential if we're ever going to truly trust these systems.
And that leaves us with the ultimate question, doesn't it? We've seen how AI is making this incredible leap from just predicting words to actually taking action. We've seen how all that power rests on a solid foundation of well-architected data governed by strict rules. But as this technology keeps accelerating at a dizzying pace, the single biggest challenge ahead is this: how do we build these incredibly powerful systems in a way that ensures they stay fair, they stay transparent, and, most importantly, they stay aligned with our deepest human values?